Draw the equipotential surface corresponding to a uniform electric field in the z direction. This is the equipotential surface, and the electric field moves in the z direction in this way. In this direction, it will be move. This is the equipotential surface corresponding to the uniform electric field in the z direction. Part B. Derive an expression for the electric potential at any point along the axial line of an electric dipole. See the diagram here. This is the electric dipole. This is point O, and here the minus Q, and here is the plus Q. The point minus Q, it is denoted by the A, and plus Q, it is the B, and from center to B it is A, and center to minus Q it is also A distance. From center the O to the point P, the distance is R minus the total, it is equal to R, and from point B to P is R minus A, and from total distance from this point to this point is R plus A. Then potential at point P is that is Vp is equal to V minus Q to V plus Q. Then which is, can write it as 1 upon 4 pi epsilon naught times minus Q divided by R plus A plus 1 upon 4 pi epsilon naught into plus Q divided by distance R minus A. Then we can write this one as, we can take the common factor Q upon 4 pi epsilon naught, then 1 upon R minus A minus 1 upon R plus A. Then we can write the same one like equal to Q upon 4 pi epsilon naught. Take the LCM, then we'll get the value R plus A minus R plus A whole divided by R minus A into R plus A. Then we get the value Q upon 4 pi epsilon naught times 2A, because minus A or A will get cancelled, 2A into R square minus A square. We'll get the value Q times 2A upon 4 pi epsilon naught times R square minus A square. Then we can write it as 1 upon 4 pi epsilon naught times P divided by R square minus A square.